Okay, before we start today's lecture, I just want to tell you in the next section, in the next lecture, we will be doing geo visualization in Tableau. So for that, you need to download Tableau. If you are a student or if you are a researcher, then Tableau is free. Otherwise, you will get a 15-day trial. So basically, what you have to do is you just Google Tableau for students. Okay. So make sure you install this before the next class. That is on Monday. So make sure you install it. So just go here for Tableau for students. And when you click here, it will say Tableau for free. So if you download it, otherwise it is not free. It will be like for 15 days. So it is just simply that it gets downloaded and asks to create a login. Once it is downloaded, it looks like something like this, right? So it does not even ask for like I think just it needs is the your university email, right? I think so. So for students it is free. This is just this is the form. You don't even have to, maybe your local Gmail will also work. I'm not sure, but just this form and you can download it directly. Okay. So Tableau is basically for data visualization in like creating dynamic maps. So not a static map, it creates more of a dynamic maps and they can be used for visualization. Now let me give you some examples. So you create something in it that is called as dashboard. Okay. So mm, so if you look here, this is a dashboard created by someone. So there is some kind of data here. Once you click that data, it gets selected and so for example, this someone has shown the height of the population area based on the height. So this area has the largest population. So something similar to this, then if it is working, let us see. So this is something that you can create in Tableau. So location wise, the data is created. Now there is this possibility for in Tableau that you can manipulate the data, filter out the data. So for example, there is time index. So at 3, for example, 9 a.m. the morning, people are more here. Maybe this is an office or something. So by the evening, they go away. That means you can predict this is an office area, right? Similarly, depends on the days. This data every different day is like you can select the regions where you want to show your area of data. So maybe just one region. So this is all what you can do in Tableau. You can, based on what kind of your data is, you can visualize it and in a dynamic manner. Okay. I'll just share this link, go through it, and the next time we will learn how to create things like this. Okay. Now, today we are going to do some three simple, very basic QGIS exercises. Now, today's class is more dedicated to practical, to all of the things that we have already learned. Now, practicals are important here because you need to get familiar, very familiar to QGIS, ArcGIS, how things work in QGIS, ArcGIS, okay? How you can work around with a vector, with a raster, right? So, though we have done many of the examples before, okay? So, for example, this tutorial, I'll share with you. So, what happens is, for example, whenever you take a study area, maybe this is your study area, okay? So, whenever you download them, maybe all of the Sri Lanka is my study area. But whenever you download a digital elevation model from the internet, so it is in small bits by bits, parts by parts. Okay. So it is in parts by parts. Now, if you want to combine that data, that is a DEM, you want to combine it into a single form. How can you do it? Or how can you visualize the DEM more accurately? Okay. So, for example, in this, they have given the data here. These are these small tiles of digital elevation model. Okay. And this is one shapefile of the Sri Lanka. Now, it is in a zip file here. Everything is different. I can give you a single shapefile, single uh, zip file. So if you want to do it along, you can just simply download this file and extract it. Okay. And the another one is this one. So now after I open my QGIS, let me load this file from here. Okay. So just select the HGT file. HGT is a format very similar to TIFF. Okay. It is also one of a raster format. Okay. So just select .hgt and drag it into your QGIS. So once you drag it into your QGIS, you will see that this is your different DEM. Now they look weird, right? They don't look normal. So this is because we have not merged it because this is different. So everyone has a number from 7 to 2510. They are not all homogeneous, right? So that is why they look different. So whenever you are working with the raster DEM and many DEMs like together, you need to make sure that you have to merge it before using it like this. If you use it like this, then it will probably go wrong. Your data will go wrong. So when you have more than one DEM, you first need to merge it. Okay. So merging is also called as mosaicing. Mosaicing means to add something to another thing. Okay. Now, The first thing is to go to your toolbox and look for merge in the GDAL library. Okay. So if I go here and I look for merge, simply select all of them and press OK. Okay. And because the original data type they have mentioned here, it is in int. Okay. So it says because the data type is in int 16, we have to change float 32 to int 16. What this is means is whenever, I mean, whosoever created this dem, they chose the data type as int. So we are keeping it same. We don't want to change. Okay. So int 16. And there is this profile. So because if you combine these dems, it will become a very large file. We don't want a very heavy file. So in this profile, you will find different levels of compression. High, low, okay. So that is the merge tool in GDAL where you are having you are doing the mosaicing, you are doing the merging, right? And you have the compression possibility also. So maybe you just want to give it as an image to someone. You can directly change it into a JPG compression. It will be very lightweight. Okay. So let me select high compression. If you want to save the output, you can save it here and simply run. So this may take a minute or two. So you see what it took was it merged all of them into a common value now. Now it is not looking weird like before, right? So it merged all of them. Now it is a single dem. Earlier it was looking like this. Now it all got merged. Now, once it is merged, now there is an option to create a hillshade out of it. Okay. Also, there is one another option because it varies over a very big range. It is from -14 to 2371. Okay. So there is an option if you want to just visualize your dem better. Okay. If you just want to visualize your dem better, what you can do is you can change the values of the range to a very small value. Now, what I mean is, generally when we download a dem, it is from 0 to 255. Okay. So that is so that you are able to see much contrast in the dem. So for example, here you were able to visualize something, right? When it got merged, it took the complete range of these values. So when you see it in the complete range, you are unable to visualize anything. Okay. You can simply go to properties, change its minimum maximum to something else. For example, uh, So let me change it to 0 to 255 and apply. Now if you see, you can visualize it much better, right? So similarly, if you decrease the value more, maybe 150, you will be able to visualize even more. Okay. But there is a downside of the visualization also. So because the data is more concentrated here, the data got smoothened out. So this thing was not visible before. You are able to see this, but this area got super bright because it falls into the top values. Okay. So let us change it to minus 14 to 2371. Yeah. Now you can see this areas. Now, if you want to see, visualize a DEM, if you want to properly visualize a DEM, there is something called as hillshade. So, hillshade is necessary and it is a very good function to visualize DEMs. Okay. So, we will create a hillshade out of this. Simply just select this and click on the layer styling. Okay. Right. And in this single band gray, just simply choose hillshade. So now you can see how the mountains actually look, how the area is actually looking. See, this feature is so clearly visible, right? So I have already told you in a class that what hillshade is, but maybe to understand again. So it is a shaded relief map of elevation by simulating a hypothetical light source, right? So based on the DEM, it creates a shaded relief map that which side of the hill is maybe lightened up, another side is dark. So, right. Now you can also clip this. So there is the feature to clip simply just you can simply go to in your toolbox, look for clip by mask layer, clip vector by mask layer. No, sorry, clip raster by mask layer. Okay. So you can just simply select the merged here and add the another one that I have given you shapefile. So this is the shapefile. I just want to clip this part, right? So we can simply look for continent here, continent or country. Maybe it's in Soviet Sri Lanka. So it is here. So if I select this, it will get selected. Or maybe what you can do is simply the attribute table. Sovereign. Just right click because this is a whole file. I want to just select Sri Lanka out of this. What I can do is simply right click and go to filter. Okay. Now in filter, I knew that the attribute name was Sovereign and I can choose sample. So here I know, sorry, Sovereign and all. So here I know there is Sri Lanka also, right? So Sovereign is equal to Sri Lanka and click OK. So this is a way that you can filter out your data from a, for example, it was a complete world map. I just wanted to use one part of it. So when you right click, there is an option called filter. Okay. So maybe there is an option here by the name of country. Country is equal to Sri Lanka. Okay. So this filter is very useful. For example, you have the whole of India's map. Okay. You just want to work with two states. So you can simply filter them and select those two states, right? So once I have the data, clip raster by mask layer. Here, make sure that this is checked. Match the extent of the clip raster to the extent of the mask layer. So if you don't check this, it will form a rectangle like this. But if you check this option, it will strictly follow the boundary of this layer. Then it will clip the below layer into this boundary. Okay. And then there is another important option. Here again, profile, you can do high compression because otherwise it takes a lot of time when you work with them. So high compression makes it quick. Okay. So maybe just run. So it got clipped wrong because we selected it match the extent of the clip raster to the extent of the mask layer. So let us try again. There is this problem in QGIS because if you check that, it will come like this only. So this was the final layer, and here is the filtered Sri Lanka file. So when clipped here using the same match the extent of the clip raster to the extent of the mask layer, only this part gets extracted. Okay. So maybe there is a bug in my QGIS for now, but this is your final hillshade or dem. Okay. Now there is one very common thing that some people ask. So because this is a dem, right? A dem is of a different place, so elevation can be different. Okay. But what if you are working with, for example, precipitation data? Okay. Now government defines a standard. Government says that the precipitation data, maybe it says that there is some value that maybe in 1 hour from 0 to 200 millimeter, or maybe this is there is a precipitation limit. So now you have a particular range, right? You cannot have a value above this because there is a threshold defined by the government, and this is the minimum value. So in that cases, what you do is, for example, you have the uh, precipitation raster of different areas, but adjoining areas. Okay. And their values are different. For example, from 10 to 180, 20 to 140. Then what you can do is you can initially change all of them to 0 to 200 because the value ranges between this value only, and then merge it. It will give a better result. Okay. So any doubts in this one? Then the next exercise that we are going to do today is it is about automated map creation with print layout atlas. Now what it means is, let me share it with you if you are doing it alone. So for example, if you have a data, for example, this person is giving us this data altogether. Now he wants to create 5 maps of this data, and we want to keep the format same, and we just want to quickly create 5 maps of this area. So, for example, if you are working with maybe population data of states of India, okay, and you want to create a map of all the states together. I mean, one by one, you want to create all the maps of all the states, okay. So that will be a time-taking process, right? So there is this something called as Atlas option in QGIS, and how it works, we will see, okay. So first of all, in this link, you need to download this data, that is the HI wetlands and the country10.shp. Just simply unzip the data. Now first locate the HI wetland shapefile here, that is in this. So just locate the uh, HI wetland underscore poly shapefile. So this is the one. Simply drag it into your QGIS. Now you can see some different islands. Okay. Since we want to make separate wetlands, okay. Since we want to make separate wetland map for each country in this state, we will need the country boundaries layer. Browse the country file and expand it, and open the file and move it to canvas. So just look for the country shapefile here, county shapefile, sorry, and move it to your QGIS. So you can exactly see the boundaries. Turn off the visibility of HI poly layer temporarily. You will see the polygons from the county 10 layer clearly now. So just for a moment, remove the other one. So this is the file of boundary of the counties. Okay. So county is like a small province. County is a American English word. It is representing small provinces, small cities or small villages, right? Okay. Now let us turn on the visibility. So go to your new print layout section, project, new print layout. Select a name for it. Maybe let us call it one. Okay. So once your map opens, go to layout, items. Go to add items and click on add map. Draw a rectangle while holding the left mouse button where you would like to insert the map. Okay. So that is button is here also if you remember add map. So you can just simply select the area of output. Okay. Now in QGIS 3, the Atlas tab is not visible by default. Select View, Panels and Atlas. Now go to View. Okay. So for us, we have Atlas here also. But is it in there also? View, Panels and Atlas. Okay. Just check it. So what you basically did was, if you see here, there are options here, layout, item properties, guidelines. So there is something called as Atlas. So you just turned on the panel for the Atlas. Okay. Click on Atlas. Click click on a generate an Atlas. Select the county 10 as the coverage layer. So here in coverage layer, select the county 10. Okay. Now, why did we select county 10? Selecting this, it indicates that we want to create one map each for every polygon feature in the county 10. Now, just let me explain it again to you. For example, if you have a India shapefile of all the states, okay, or whichever country of yours, okay. Now you want to create a map state by state, right? So here in Atlas, in coverage layer, you will select the layer of which all the polygons will be represented one by one as a map. Okay. So in that case, it will be India. In this case, we are selecting county 10 because we want to show it one by one. Okay. Select the hidden coverage layer. Then switch to the item properties tab. Scroll down and check the controlled by Atlas box. Scroll down. We don't have the option this in this QGIS.
Sir, you have controlled by Atlas. You have in
Pardon?
the item properties you have controlled by Atlas. That's
Ah,
here.
thank you, thank you. Okay. So what I did wrong was I did not select this. After selecting, I got the option. Okay. So once I select the control by Atlas, scroll down and check the control by Atlas box. This will indicate the layout that the content of the map displayed by in this item will be determined by the Atlas tool. Okay. So in Atlas, you selected the shapefile. Now the layout of this map will be determined by the Atlas tool. Okay. Now that you have configuring the Atlas settings, go to Atlas and click on Preview Atlas. Preview Atlas. You will see that the map refreshes and show how individual map will look like. You can preview how the map will look like for each country county polygon. Go to Atlas next feature. Atlas will render the map to the extent of the next feature in the coverage layer. Now you can add a common label to everyone, or you can add customized label to everyone based on each map, right? So simply go to add item, add label, select whatever you want to add, maybe in this, and select the lorem ipsum here. The label. Now there is an option. So if you see here, there is an option to edit expression. Now what it means is maybe I have 100 polygons of that file. I have one single polygon. I have one single shape file, but inside there are 100 polygons, and I don't want to take time to change each of its name. Okay. So what I can do is there is an edit expression option here. So in that expression, I can add a name and give some command where it will pick the name of the shapefile itself. Or maybe it will pick the name of in the attribute itself. For example, in attribute, if this county's name is something, it will pick it. Okay. So in this uh, county shapefile, we have name 10 where the name of the county is there. Okay. So we write a code where we are saying concatenate. Concatenate means adding two names. Okay. So this is what we are writing, that is county of, we are writing it as a string. And then there is name 10 which is being added from the attribute file. Okay. So just simply copy this and in edit expression, just put this. So it will appear like county of Hawaii. Okay. And just simply press OK. Just make sure to remove this lorem ipsum and then press OK. Deleting the leading lorem ipsum placeholder so that the text box contains only the expression. Scroll down to the appearance section and click on the font drop down. Choose the font and adjust to your liking. So there are other properties here. Horizontal alignment, vertical alignment. You can change as you want. Then you can add another label. We can call it wetland map simply. So add item, add label. So this one has to be remain common in the expression, that is wetland map. So with each map, I want the county name to be changed, but here I want it to remain same, that is wetland map. Go to Atlas to last feature and verify that the map labels do work. Okay. So Atlas last feature. So wetland map should remain and county should change. So this is county of Moi, right? So with every feature, This remains same and this is changing. Switch to the main QGIS window. Right click County 10 layer and select Properties. In the Symbology tab, select the inverted polygon render, the render style, the outside of the polygon, not inside. Select white as the fill color and click OK. So just check for you if this render is working, inverted polygons. Okay. So once you click on this inverted polygons, that polygons extending outside of the country boundaries are now disappeared. In reality, they are hidden by white color fill extending out of the country polygons. Good. So switch to layout window. If we want the effect of inverted polygons to show, we need to uncheck the hidden coverage layer box under Atlas tab. So for us, this is maybe showing here, but according to the tutorial, this should, maybe my QGIS has some bugs. Okay. So if it is looking for you like this, it is great, right? Now, there is one more problem though. You will notice in that some cases parts of the maps that are outside the coverage layer boundary are still visible. This is because Atlas doesn't automatically hide other features. This can be useful in some cases, but for purpose we only want to show wetlands of those country whose map is being generated. To fix this, switch back to the main QGIS window and right click on the County 10 layer and change the single symbol to rule based. Now in rule based, edit the expression, and in this expression add the ID, this one, Atlas feature ID. So what it does is there is a there is an attribute there that represents based on the Atlas feature ID. So let me choose the expression here. Now for them it is working, but in our I think there is some problem. So anyways, this is more symbology changes in the color symbology for maps, giving a background, giving a color to the wetlands, right? So you can follow this tutorial for more. But basically you need to understand that there is something called as atlas, and that atlas is used to create many maps out of a single file. Okay. So for example, if you are working in population survey company, okay, now they gave you today a list of 100 cities and they tell you by tomorrow you need to create the population map. Okay. So how will you create the population map so quickly for all of them? The only option to do is through Atlas. Okay. So I hope the meaning of Atlas in the working of Atlas is clear to you. Okay. Any doubts in Atlas? Okay. So the next tutorial that we are going to do, it is that we are going to create, first of all, create some river basins and then give it a color. Okay. So just follow the tutorial. So in this tutorial, we will take data layers of basin and rivers from hydrosheds and create a basin map for rivers of India. Okay. So just scroll down. Just go to this website, Hydro Basins, or maybe just, uh, yeah, simply go to Hydro Basins. Look for your region. So for example, we are in Asia. Double click on Asia. And in Asia, look for Asia 06 standard 13 MB. Double click on this and it will start downloading, right? Then after hydro basins, this is hydro rivers. So these are all the basins and lakes and everything about uh, related to water bodies is available on this website for all of the world. Okay. So then just go to hydro rivers, look for Asia again and download. We will clip the hydrosheds data to the boundary of your chosen region. In this tutorial, we want to create a river basin map of India. So we will get the boundary shape file from Survey of India. Visit the Outline Maps of India page and download the international boundary, Indian international boundary in vector format. Okay. Mm, So this is at the top of it. Once all the files are downloaded, unzip them and copy them to a folder. You should now have three shape files, right? So simply create a folder and copy all the three to it. Unzip it. Right. Now open your QGIS and locate the downloaded files and drag these two files to your QGIS. So in your QGIS, we are going to drag Ibis AS, that is this one, Ibis AS, ASHP, and these are water basins, river shed basins. So a river spreads across this much area, right? So, uh, and then the hydro rivers, SHP. So because this is a geo database, hydro rivers. Because this is a geo database, you need to open it like this. Click on source type database. Uh, Select selected data set. So in database, select ISNI personal database. Click on new. There is the option to add a database. Has anyone added a database to QGIS before? Uh, yeah. So just go to source type directory and in type, select the open file GDB. Okay. So once you click it, there will be an option to add. Once you add, you will be seeing this layer. Okay. So add layer and close. Now I have the river shape file. So if you see here, I have all the rivers here, right? So once you add it to the canvas, locate the administrative shapefile boundaries in outline of India. Just pick the outline of India and drag it here. So first of all, you see that this is the boundary. The hydrosheds data layers have some features with invalid geometries. Let's fix them proceeding further. So if you remember from last class, fixing geometries is, for example, the hydro shed data here is not complete polygons or something missing polygons, right? So that we will fix from using fixed geometries. Okay. So just simply look for fixed geometries in your data here. Fix in your toolbar, fixed geometries and double click it. Select the hype bars and save the data as a geo package. So once you add this name, basin fixed, click OK. Next, click run to run the algorithm. So now it has corrected all the polygons. So every polygon is now complete. It is not broken anywhere. Okay. So the geometries are complete. Now you can initially, if it was broken, you could not calculate area of every polygon. But now you can calculate area of every polygon. Okay. Repeat the step for hydro river also. Okay. So you go here, you go select hydro river, save data as a geo package. Output name, data pendant is the layer name. Simply run it. Now both the layers have been fixed with the geometry. The outline data of India, it is having a projection system that is not recognized by QGIS. So we will have to reproject the area. Okay. Or in general, we have to assign it a projection system. Okay. So if the projection system is not already assigned, you can assign a projection system. So there is this option here called as assign projection. Double click it. Okay. So input layer is the remember that assign projection does not reproject the layer but simply adds the correct projection system to an existing georeference layer with a missing or incorrect projection. Okay. Use the reproject layer if you want to change the CRS of a layer. So for our layer, we have a coordinate reference system. We choose outline of India, 7755. We choose 7755. Admin boundary fixed. You will have three new layers: basin fixed, reverse fixed, admin boundary fixed loaded to the panel in QGIS. Hold the shift key and select all the remaining layers and remove them. Okay. We will now clip the basins and river layers to the administrative boundary. Search and locate the vector overlay clip tool. Okay. So we will simply clip the data now. In vector overlay, uh, choose the simple flip. Select basin fixed, overlay layer as admin boundary. Save the output as data.geo package. Name it as basin clipped and click run. So we do not have a basin clip file. I think there is a problem with my QGIS. Anyways, so when you clip both the files, you will get the clipped version and you can remove all the rest of the files. Okay. Once you have the basin clipped and you have the river clipped to the extent of the Indian shape file, save it to simply go to project and save it as a geo package. Okay. So now there is a feature in QGIS, it is called as topological coloring. Okay. So in that topological coloring, just select the basin and select the save feature. So in topological coloring, based on the elevation and based on the spatial relation of different layers, it will give it a color ID. Okay. Now, then after that, join the attributes by location. So, if you remember, we did it in the very first class to join the attributes of two shapefiles. Okay. So here we are doing the intersect and we are giving the color from one ID to another. So simply when you select it, it will be transferred. Then there is the option to layer style the admin boundary. Simply based on category, choose the categorize option. Okay. In categorize, choose the color ID. So based on color ID, it will be given a color like this. In this color, now we want it to be transparent. Okay. So there will be a symbol option. Just change it to this line. Okay. And change these font accordingly. So then there you have to add an expression about the Strahler order. So if you remember the Strahler order, there is a field based on the Strahler order in the river with color. Simply go to the assistant and in there select the Strahler order and the colors based on it. So size of the rivers. Okay. So then you should follow simply the styling of the layer here if it is in millimeters, meters, and simply when you now these are simple print options to add it to a map. You can follow them. You can add pictures, logos to the map, and you will be finally able to create a map like this. Okay, so you can see how colorful it is, right? So based on your data from wherever you have the data, you can create a map like this. Okay, just practice the tutorial. In my QGIS, it is showing some problems. Maybe I have to change the version of QGIS. I will look into it. Okay. And for the next class, please make sure to download Tableau. Okay. So we will be working with Tableau. So there are some geo visualization possibilities that we can do in Tableau. We will be doing that. Okay. Okay. If any doubts, you can ask. Otherwise, we will meet on Monday. Okay then.